14, Section 3, lecture notes, river valleys. Key idea of river valleys is that the continuous running water tends to form V-shaped valleys that grow longer and wider over time. So when you look at a map or a satellite picture of a river, you can guess it's an educated guess of a river's age by the type of river valley that it has. And an example again is if you look at a river like the Mississippi, a wide, fairly flat valley, you can tell that that's a fairly old river. The objectives of Section 3, we're going to learn and explain how river valleys form, then I'll describe the formation of rapids and waterfalls. Headward erosion, excuse me. A single heavy rain may form a small valley in loose soil along a hill slope. When the rain ends, the stream may disappear, but the small valley remains. Such a feature is called a gully, and you all know what gullies are. Gullies grow in length, width, and depth with every new rain. The process by which land is worn away at the head of a stream or gully is called headward erosion. It continues to creep or advance. If the valley grows in length and depth, the stream may cut down far enough to become permanent. When the tributary gullies also become permanent, then a river system is born. This is an example of gullies. This is another example of gullies and headward erosion in the Badlands National Monument of South Dakota. Canyons. A canyon is a river valley that has very steep, almost vertical sides. Canyons are also called gorges or chasms, and canyons form in regions with little rain. When the river cuts into its bed rapidly due to bed load erosion. This is a picture of the Grand Canyon. This is a gorge. V-shaped river valley. Most, as I said earlier, most youthful river valleys are V-shaped. Such valleys are found in regions where there is enough rain to erode the sides of the valley. As the river cuts its way down into its channel, the upper valley walls are widened into a V-shape by erosion. How V-shaped valleys form? The valley forms gradually by lateral, which means this way to the sides, in addition to the downward erosion of the channel. In this example, the river cuts down and deepens its valley. The river widens its valley as it deepens, and then the river continues to widen its valley. This is a typical V-shaped valley, a fairly young river. The base level of the river. Base level of a river is the level of the largest body of water into which it flows. For streams that flow into the ocean, the base level is sea level. The base level of the Fox River is the Bay of Green Bay. Sea level is the ultimate base level because ultimately all rivers will eventually empty there. Lakes and rivers also are local base levels for streams that run into them. Stream piracy. Stream piracy or stream capture takes place when headward erosion. Stream piracy or stream capture takes place when through headward erosion, one of the rivers wears through the divide and captures the headwaters of the other river. The first river grows larger and extends its drainage basin at the expense of the captured river. This picture illustrates some stream piracy. As you can see, it probably flows in this direction, and this river system probably captured this river as it flowed in, and you can see how it changed the channel, and eventually this river became bigger. Rapids and waterfalls. When a riverbed is steep enough, the river forms whitewater rapids. It may level off into a lake or a pond, or the stream may plunge over a cliff to form a waterfall. Stream erosion is greatest at rapids and waterfalls because of the velocity and kinetic energy of the water. Erosion created by waterfalls. One way a stream erodes at waterfalls is by undermining. Undermining happens when water falling into the plunge pool at the base of the waterfall erodes the rocks there, leaving the rocks at the top of the falls to overhang, or the rocks at the top of the falls to overhang. When pieces fall from the top, the waterfall recedes or moves upstream. It's a picture of a waterfall, and the undercutting, you can't really see it here, but underneath this whiter water, the rock is eroding away, and the wall is being undermined and moving back. And a lot of this happens a lot in the Niagara Falls area. That falls used to be a lot farther east than they are today because of erosion caused by the water. The horseshoe effect that Niagara Falls has been moved back. Niagara Falls, typical example of waterfalls that recede by undermining. The rocks underneath the waterfall consist of alternating layers of resistant dolomite, dolostone, sandstone, and shale. Dolostone is more resistant to erosion than the softer shale at the base of the waterfall. As the shale at the base of the waterfall is eroded, the riverbed undergoes regressive erosion. This is what's happening in this diagram, illustrates what's happening at Niagara Falls. The different rock formations we have there, they're in the Silurian period, which we'll get to later. The different ages or epochs and eons of rocks. We have the Lockport dolomite on top of the Rochester shale, on top of the Clinton limestone and shale, the Medina sandstone, Cataract shale and sandstone, and Queenstone shale. So we have alternating layers of harder and softer rock, and Niagara Falls is undermining or cutting back into the exposed rock wall. Famous waterfalls. The highest waterfall in the world is Angel Falls in Venezuela. Height is 975 meters. Tugela Falls, second highest waterfall, 947 meters. It's located in South Africa. Victoria Falls in Africa is considered the largest waterfall in the world. It is 1.7 kilometers wide, and its maximum height is 106 meters. Niagara Falls is one of the largest waterfalls in the world. It discharges over 6 million cubic meters of water per second. And then Yosemite Falls is the highest in the United States at 1,430 feet. Picture of Angel Falls in Venezuela. Victoria Falls. And Niagara Falls. And as I said, Niagara Falls, the face of Niagara Falls used to be a lot farther east, and as the rock is eroded, Niagara Falls is retreating back to the west. This is Yosemite's Upper Falls. Pretty spectacular. A pretty deep plunge pool, you can bet, here at the base of the falls. That concludes the lecture notes for Section 3, and the Section 3 online review will be posted in your My Big Campus account.